So the next question is asking for the grams of C38 as opposed to the moles. That's the difference between them. So you're still given the 1.65 moles of CO2. So it's asking you now to give the answer in grams. Now, what I did here is I simply just wrote the equation again because don't want to just keep looking up all the time. And again, I copied those ratios as we did. We might do them again down here as well. Quickly, if I see the word grams of that substance, I will automatically do the same thing. The following thing is I will calculate the molar mass. So I will go and find the molar mass of C3H8. Now, this was done already right here. And that's 3 carbons, 8 hydrogens from the periodic table. That comes out to be 44.11 grams of C3H8, which is equal to 1 mole of C3H8. And then, since we said the ratio, since you have going from one compound to another, that numerical relationship has to involve the mole ratio. So in this case, the ratio of CO2 to C3H8, as in the last problem, it's 3 to 1. Good. So now we have 3 moles of CO2 to 1 mole of C3H8. So this is all the info that I need to calculate the grams of C3H8, 2 conversion factors. So I'm going to start with 1.65 moles, just like I did in the previous problem, and end with the grams of C3H8. Okay, so dimensional analysis all over again. All I need to do is make sure I know how they fit in here. So if I have moles of CO2, I'm going to look for the one that has moles of CO2, and that is this one right here. So I have 3 moles of CO2 to 1 mole of C3H8. The unit cancels out. So I use the ratio first. What I like to do is, again, cross it out so that I don't have, cross it off so I don't have to use it again. Now the next thing is what I have is this. So I have 1 mole of C3H8, and that would be 44.11 grams of C3H8. So I'm left with, again, grams, which is right here. Very well. So you multiply across and then you divide by 3. Which gives me that I need 3 sig figs. So I need 3 sig figs, which comes out to be 24.3 grams. That's how I do the problem. Now the next problem is asking you to go from grams to grams. So right away, when I think about when I see grams, I go ahead and write the molar masses of each. So we did the molar mass of C3H8. That was, let me use blue once again. I need the molar mass now of CO2, which is 44.01. 1 mole of CO2. Again, this is from the periodic table. This is all from the periodic table. You add up the numbers. And then finally the ratio. So that would be the same from CO2 to C3H8. It's like the last one. Or here it is 3 to 1 once again. So that would be 3 moles of CO2 to 1 mole of C3H8. Very well. So I'm asked to start with 72.6 grams and to end with the grams of C3H8. Now, if you think about this a little bit in depth, you'll find that all that this was asking you is that to start with the grams rather than the moles. What happened here is you started with the moles. But of course, in the lab, this is not practical because we don't have a balance to weigh the moles. It's a counting unit. So we count by weighing. So very well. Let's start. If we have 3, let's start. Think about it. Which one should we use first? If I have grams of CO2, then that what should go down here. Exactly, it would be this one. So that's 44.01 grams of CO2. That would be 1 mole of CO2. Now, if you have a calculator, what you should be doing now is take that 72.6 and divide by the 44.01 because it's in the denominator. So if you do that, you actually get 1.65. I don't want to make this too noisy here with the writing, but that would be 1.65 moles, right? So you're starting from there. So again, you achieved this by converting the grams to moles, which is basically what the previous problem started with. But let's continue. So if we use this one, then is it going to be any different than these? Nope. I'm going to continue now. So what would come next? It would be moles of CO2 on the bottom here. So we would have to use this. And then 1 mole of C3H8. What should come next is the last one. So it would be 1 mole of C3H8 to cancel out the moles, and then 44.011 grams of C3H8. And if you do the problem, really the same way. Now, how do we do this mathematically? You just go into your calculator and you take 72.6 times, this is a 1 and a 1, so 44.11, hit enter. Or you can say divide, open parentheses, 44.01 times the 3 right here. The rest are 1, so they don't make a difference. So it would be 72.6 times 44.11 divided, open parentheses, 44.01 times 3. Nothing different than the last answer, 24.3. So this is how you do stoichiometry. It is quite scary at first, but it's really a matter of practicing. So please make sure you practice. I'm going to just end with this: is that there's a quick method of doing it. Have it handy. Is that you start with grams of A, you end with grams of B. These are two different substances like CO2 and C3H8. It always goes like this: divide by molar mass of A, multiply by the ratio, and then multiply by the molar mass of B. It is always this way. Now, you might say, well, what's in between? What if I stop here? Well, then that would be the mole of A. Well, what if I stop here? Then that would be the mole of B. So help you understand it. Now, some problems, as I say here, can involve dimensional analysis. So you could be given the amounts in pounds and have to convert to grams, and so on and so forth. So always be able to combine these skills in solving these, what we call cumulative problems.